This is section 8.6, common logs. If nothing is written in common logs, you should be excited because you can use your calculator to do these. You can calculate these answers with this lovely calculator. You do need that LOG button on your calculator. So if you're using mine, it definitely has it, but if you have your own, be sure it has an LOG button. Michael, do you have yours? Does it have it on there? You guys have their own. Is yours good? No. Lance, you're good. Creative, are you good? Good log. Yeah. Yes, I'm on. Cindy, are you good? Spina? Yours has a lot more. Anybody else have their own calculator? Common logs. There's all different kinds of logarithms. Yes, ma'am. Thank you. There's all different kinds of logarithms. We have common logs. There's common logs. There's natural logs. Do you see an LN button on your calculator? LN, that's natural log. LOG, that's the common log. And then there's logarithms with different bases. And really up to this point, we've been working with logarithms with different bases. The common log, as I'm referring to that, common log is going to look like this. It has a base of 10. It has a base of 10. Common log has a base of 10. If it has a base of anything else, it's not considered a common log. It has to have a base of 10. Sometimes what they'll do is they'll show you that common logs are so common, it's understood that you have a base of 10. So if there is no base, it's understood to be a common log and have a base of 10. Kind of like if there's an x, we know there's a 1 in front of that x, right? If we just have the variable x, we know that the coefficient in front of that would be a 1. That's one of those things we just understood. Same thing with logarithms. If there's not a base in there, it's understood to be a base of 10, a common log. Now I mentioned natural log. That's the LN button on your calculator. Natural log has a base of e. E is actually a number, not just a variable. E is a number, kind of like pi is a number. And there's different instances where common logs may be more useful than natural logs. In Algebra 2, I'm going to introduce you to common logs. I'm really not going to spend a lot of time with natural logs in here. You'll probably get more into that when you get to college algebra. So I want you to be familiar. You've seen that, natural log. If on an EOC or maybe ACT they ask you to calculate a natural log, you may be able to use your calculator to do that. So now I'm pushing a button. And we'll talk about that in a little while. So let's utilize our calculator to calculate some of these logarithms. In this next slide, it says use a calculator to evaluate each expression to the nearest 10,000. Now, if you're looking at these three problems, they don't have a base. What do we know it is? It has a base of 10. In other words, it's a common log. So on our calculator, let me open mine. Our first problem was log of 101. Log of 101. I'm just going to literally type it into my calculator. Log. I'm just click the log button. 101. And then hit enter. And it should give you a decimal value. They asked us to round to the nearest 10,000. Just a refresher here. This is the tenths. Hundredths, thousand, 10,000. So how many decimal places is that? 4. I want to round to 4 decimal places. So this 2, is it going to round the 3 up, or is it going to remain a 3? Remain a 3. So this calculated answer should be 2.0043. Make sure you do round appropriately. If you need to round up, do so. Don't just cut off your decimal. Log of 2.2, let's do that one. So on my calculator, I'm going to type in log of 2.2. 0.3424. For the third one here, log of 0.05. We can type that in as well. Log 0.05. I have way too many decimals in there. Negative 1.3010. Any questions on using that log button on your calculator? It's just a matter of pushing the button. That's all it is on that. Alright, so now we're going to solve some equations that have common logs in them. If you look at this problem, please copy this down into your notes. We have 5 to the x power equals 62. 5 to the x power equals 62. Normally, what do we try to do to solve this? What? Well, it's already an exponential form. Huh?
Would you say log?
I think go the other direction. Try to get them to have the same basis. Isn't that how we solve exponentials? Try to get them to have the same basis? Okay. So let's think. I know I can break a number down. I can't build it up. So can I maybe make 62 have a base of 5? Does 5 to some power give me 62? Does it? It doesn't. I can take 5 squared, that's 25. 5 to the third is 125. I can't. Can I break 5 down at all? I can't. I can't take 2 to some power to give me 5. I can't take 1 to some power to give me 5. It doesn't work that way, can we? We have two bases that are not compatible. So here's what we're going to do. We're going to use common logarithms. We're going to use common logarithms. What we're going to do is we're going to add logarithms to both sides. We're not going to go back to logarithmic form. We're going to add logs to both sides. So literally, I'm going to write this as log of 5x. Now, what is the base here? I'm not writing in a base. What is it understood to be? Base of 10 equals log of 62. I'm just adding logs to both sides. And the reason I had to do this is I was unable to simplify my exponential equation. You know some properties of logs that you can utilize here. Where is that x going to go? To the front. We know if we have an exponent, we're going to move it out to the front. So really we have x times log 5 equals log 62. This is an equation. Can you solve this equation for x? Absolutely. What do we need to get rid of? Log 5. We're multiplying by log 5, so what undoes multiplication? Division. So we're going to divide both sides by log 5. Log 5 divided by log 5, that's going to be a number, a decimal value, which we can calculate. Those are going to cancel out, and we're left with log of 62 divided by log of 5. Now, the word log doesn't cancel out. I don't just have 62 divided by 5. I can calculate this on my calculator. I'm going to calculate it on my calculator. So let's do that. I'm going to type log of 62 divided by log of 5. So log. I am going to use parentheses here just to be on the safe side. Log of 62 divided by, what did we say it was? Log of 5. Parentheses, log of 5. Argument check.
Check. Oh, okay. 2. I put like 3.
What did I do? Oh, I did. I put too many parentheses, didn't I?
So 120.
Parentheses.
I got right now.
It's not like this. Try this again. Oh, look without parentheses. I just have too many up there. I'm not effective, didn't I?
Yeah.
There we go. Is that what you guys got as your answer? Sorry about that. So we're going to round to four decimal places. It says the nearest 10,000. Look through these 4 places. So we have x equals 2.5643.
That goes 2.58. I got 2.584.
You type in, did you read it?
I typed in 64 and I succeeded.
Any questions on this example here? How about this one? 5 to the a power equals 120. Can I break 120 down to a base of 5? Does 5 to some power give me 120? Well, 5 squared is 25. 5 to the third is 125.
No.
Can I get 120? I can't. So utilize your common logs. Let's add log to both sides. Again, in this example, we do have an exponent of a. Where's that a going to end up? It's going to go to the front, just like in that last example. We can calculate this by solving for a. What do we do to get a alone? Divide by log 5. Copying this down. So I'm left with a equals, I have log 120 divided by log 5. Can we calculate that on our calculator? Of course we can. So I have log of 120 divided by log of 5. 2.9746. Let's do this next example. It's a little bit different because we're going to have a binomial in our exponent. As you're writing this down, you're thinking 82.1. Well, we know we can't break 82.1 down to have a base of 2, can we? That doesn't work. So the only option here would be to add your logarithms to both sides. Again, we have an exponent. What's our exponent? A minus 4. So we're going to move that to the front. Now, when I move that binomial, that exponent that's a binomial, to the front, I'm going to put parentheses around it because it is more than one term. We're solving for, I don't want to distribute, that's going to be ugly here. Let's get rid of this log 2. What can we do to get rid of log 2? Divide. Divide both sides by log 2. So we're left with a minus 4 equals log of 82.1 divided by log 2. One more thing, get rid of your a. What can we do to get rid of the a?
What can we do?
Add 4, not divide by negative 4, add 4, it's minus 4. I'm going to add 4 to that logarithmic expression. Log of 82.1 divided by log 2 plus 4. I'm just going to type all that into a calculator. I'm not going to try to simplify or get each individual decimal value. I'm going to type it all in, calculate it. What's that going to look like? We have log of 82.1 divided by log 2. Now, I'm not going to worry about the 4 just yet. I'm going to go ahead and hit enter. And then what can I do to that answer? Just add 4 now. So it's going to bring down as a and s, which means bring down the previous answer, plus 4. So 10.359. I think I'm going to stop here because I want you guys to be able to start on some of the homework problems. We're solving for logarithms. Remember, if we're using common log, what is the base understood to be? 10. If it's any other base, is that considered a common log? It's not. It has to have a base of 10 or no base there. It's understood to be a 10. Homework is out of your book on page 519. We are still looking at a quiz on Friday. Logarithms. We'll talk more about that quiz tomorrow in class, but it's going to be on your radar. Don't forget about your study guide. How are we coming along with that? When's it due? Monday. It is due Monday, so make sure you're not started. Don't wait until the last minute to do that. Please be aware of the directions. If they tell you to round to 4 decimal places, please do that.